Hello, my dear students and the rest of the learners. Welcome to part 25 of a 95-part series of tutorials in object-oriented programming in C++. In this presentation, we are going to look at the implementation of objects and the classes, or we are going to continue looking at the topic implementation of objects and the classes. And our focus in this presentation will be on what we call the use of implicit pointer or this pointer. My name is MemJM, or you can simply call me Emily Swap. What is this pointer? This pointer is a constant pointer. It is a pointer accessible only within the non-static member functions of a class, a struct, or union type. It points to the object for which the member function is called. Static member functions do not have this pointer. In other words, we make use of the implicit pointer or the pointer we call this pointer when we are dealing with dynamic objects or free stores or dynamic memory. And therefore, we use this pointer when we are manipulating a memory that we allocate when we want to use and we deallocate when we don't need it. And remember that when we are talking about free store or dynamic memory, the programs implementing that kind of memory or that kind of memory allocation makes use of pointers, and the members are dynamic. So we make use of new operators and then delete operators. So the keyword this identifies a special type of a pointer. Suppose that you create an object named discourse of class students, and class students has a non-static member function called results. When we talk about non-static member function, we are talking about dynamic function. If you call the function scores dot results, or when you call results, which is a member of the class called scores, or let me put it another way, if you invoke results function through an instance of the class, the instance having the name scores, then the keyword this in the body of the method, that is in the body of result function, will store the address of scores. And what is scores? We have said that scores will be an object. Object for what? An object for manipulating the members of a class called students. And therefore, if you call the function results through the instance of the object called scores, the keyword this in the body of that function stores the address of the object. You cannot declare this pointer or make assignment to it. A static member function, therefore, does not have this pointer. The type of this pointer for a member function of a class type, for example, the scores, can be written undeclared as scores const. A scores being what? Pointer. Being the pointer. Pointer pointing to scores. And it is constant. If the number function is declared with the const qualifier, the type of this pointer for that member function for a class scores will be const scores pointer, then const. A const, this pointer, can be used only with const member functions. Data members of the class will be constant within that function. The function is still able to change the values, but requires a const cast to do so. If the member function is declared with a volatile qualifier, the type of the this pointer for that member function for class, for example, for class called scores will be volatile scores pointer const. My dear students and the rest of the learners, may I still remind you that if you have issues understanding how pointers work, kindly go through the tutorial by or that is talking about pointers under the C++ computer programming series so that you are able to link the knowledge of pointers to the use of the pointers in object-oriented programming, and so that also this context of this pointer that we are learning can be clear. So this pointer is passed on a hidden argument to all non-static member functions calls and is available as a local variable within the body of all non-static functions. For example, you can refer to the particular class object that a member function is called for by using the this pointer in the body of the member function. The this pointer always points at the object with respect to which the function was called. It is evident that the this pointer should continue to point at the same object, that is, the object with respect to which the member function has been called throughout its lifetime. The accessibility of an implicit object is the same as that of the other objects passed in parameters in the function call and the local objects inside the function. For example, the following is a sample program implementing the this pointer, and it is going to produce or give out an output which will be a equals to 5. So the following is a sample program implementing this pointer or the implicit pointer. We have the class called score, and this class has private members, and the private member in this class is a, which is of type integer. Then we have the public members who are, we have the first public member who is set a, and this function or this method, this function is going to receive a single parameter, which is of type A. And the name of this function is set A. Now, this function will do the following. Number one, it is making use of this pointer. So this pointer here is used to retrieve the data or content of the member called A through the object called score object, or the object that is supposed to manipulate the members of the class, and is hidden by the automatic variable A. So that's how we write it. So this is this pointer. You can see it is picking the content that has been received as a parameter, which is of type A or type integer. So the content that has been received through the parameter called A will be assigned to will be assigned to A, will be assigned to A. And who is this A? This A is the private member of the class called score. And that's the end of that method. The next method, or the next member of this class called score, is the method called print A. This method or this function is not expected to return any value. That's why it is void and is not receiving any parameter. So what is it going to do? Because this method is a member of the class called score, it has direct access to the private member content, who is private member by the name A. So this statement or this function is going to display on the screen A equals 2. And then the compiler is going to pick the content, of the member called A and write it out on the screen. And then a new line will be generated, or the cursor will be taken to the next line. And that will be the end of that, or that's the end of that method, and the end of the function, or the class, the end of the class. You can see this class as one data member by the name A, and two methods who are the set A, which or whose purpose mostly is to receive the data to be stored in the member on the A, and the next method is print A, whose main purpose is to display the content of the method, or the content of the member, the content of the data member called A. So we go to our main program, and our main program is beginning with declaring a static member. This is a static member. And this static member or instance is by the name score object. So this is a declaration statement for an object or instance of the class called score. So this score object is an instance or an object to be used to manipulate the contents of the class called score. Next statement is we are declaring a function, or not a function, we are declaring a variable called A, which is of type integer, and we are initializing that memory location with 5. So 5 is being assigned to the memory location that has been set aside by the name A, whose content is of type integer. This function here, or this statement here, is invoking the method called setA, and it is setting to it content, or the content of the memory location called A. That means 5 is being sent to the class through the member called setA. So setA is a function in the class called score. But for this data to be passed to that function, we must pass through the class's instance. And therefore, we are invoking the function called setA by sending to it a parameter, or the content of memory location called A, through the object called score object. So once this statement is invoked, the compiler will go to the class whose object is score object, and that class is score. And then it will move to the member called setA. So the value which has been transmitted will be received here. So A is going to receive 5. And then that value is going to be stored in the member of this class called A. And therefore, this pointer is going to be used to retrieve the content of the member called A through the object called score object hidden by the automatic variable A. So once that is done, the compiler will go back to the main program and execute the next statement. The next statement is invoking the function called print A, which is a member of the class called score. So this function, once it is invoked through the object called score object for the class, the compiler will go to the class and then come to this member who is print A. And then this message will be displayed on the screen. The content for memory location count A will be picked, being displayed out on the screen, and the cursor will be moved one line, and that will be the edge. And once that is done, this program will have completed its purpose, and therefore the control will be taken back to the operating system, and the program will end. Now, the following is a demonstration on how this program can be compounded and executed in C++ and the output that it will generate. My dear students and the rest of the learners, my usual request is copy this program. Copy this program as you can see it in your exercise book or on your editor or one processor program, or write it in your exercise book just as it is. And then once you are done, you can write it into the C++ editor, or just copy your program from your word processor and paste it in the C++ editor screen. So let me start my C++ program. Here it is. It's already open. So this is my Visual Studio or Microsoft Visual C++ 2010 program. So I'm going to create a new project. And this project is for Win32 console application. What is the name of my program? What is the name of my project? The name of my project will be, let's see if I have the name. I don't have the name. So the name of my program here, because this program, the purpose of this program is to implement this pointer, I'm going to call my project this pointer. So I'll call it this pointer. You can always give yours a name, but always remember the rules of naming variables. Always make use of names that you can remember the purpose, or that can tell you what they are all about. So we are calling a program in C++ or source code, and the name of my file or my program will be this pointer. Once we are there, I have already written my program. I have already coded my program in using WAND. So this is my program implementing this pointer. So what I'm going to do, let me just copy my program. There's the program that I've already explained to you. That's my program. Remember, you can write yours directly on this editor, or you can do just as I have done. You can write it on an editor program or a word processor program, such as Microsoft Word, WordPad, Notepad, or any other. Or you can write it in your exercise book and then write each of the statements here, type each of the statements. Once you are done, you click on Save button. From there, you compile your program. So I'm compiling my program in C++ 2010. You can see that my program has succeeded. It has no errors, and therefore, the next thing we need to do is to execute or run our program so that we can see what it is going to do. You can see this program is performing just a single task. It is simply outputting, giving us the output as A equals to 5. Which part of the program has done this. Which part of the program? It is this member here. It is the work of these two members. First of all, we have the this pointer, which has been used to retrieve the content of the variable called A through score object. So once that value has been retrieved, you can see it is the one which is being output through the method called print A. And that's the overall purpose of this program. So we are going to press hit continue. And with that, my dear students and the rest of the learners, we have come to the end of part 25 of the 95 part series, in which we have looked at what we call this pointer or implicit pointer and how we implement it. You can continue to part 26 of 95 part series, in which we are going to learn about inline functions, still under the implementation of objects and classes topic. Congratulations for learning part 25 of 95 on implicit pointer, or what we call this pointer, and implementation of objects and classes in object-oriented programming. You can access videos for the other parts in object-oriented programming series, as well as other computer or ICT videos by clicking or tapping on Implicit ICT YouTube channel below this video. Remember to subscribe to the channel by tapping on subscribe button below this video in YouTube, if it's not currently reading as subscribed. Remember, you can also join this channel as a special member, receive special offers by clicking on the join button just immediately to the channel's name, that is Implicit ICT. For any further correspondence, kindly write it to us through the email implicit@gmail.com. Thank you very much for listening to me. Let's meet in part 26 of this series, and God bless.